Lesson 4, inscribed angles. We're going to find the measure of inscribed angles. We're going to first define what they are, but we're going to find that relationship between the angles on the circle versus in the circle, and as far as they relate to the measures of the arcs, the intercepted arcs. And so here again, this is again a central angle, and the intercepted arc, RK, has the same measure as that central angle. Here, this is an inscribed angle. The vertex is on the circle, all right? And its intercepted arc is still defined in the same way. It's the measure of this arc AB. How are these measures related? We know that if this is, let's pretend that this is a diameter here, this angle is bigger than this angle, all right? How much bigger is really the question. This angle is bigger than the angle at C, but this arc's measure is the same as this angle's measure. So how is this arc's measure related to that angle's measure? That's really going to be the question of today's work, all right? And so here is our theorem 8 that says that the measure of the inscribed angle is half the measure of the intercepted arc. And so it says case 1, case 2, case 3. Those different situations don't matter. What matters is that the vertex of the inscribed angle is on the circle. It can include the center. One of the segments can include the center. It can go around the center. It can leave the center excluded from that angle, and it doesn't matter. The measure of the angle is always half the measure of the intercepted arc, half the measure of the intercepted arc, half the measure of the intercepted arc. So if we know that this angle here is 40 degrees, and this arc is 40 degrees, then this angle will be 20 degrees, right? Because if this is 40, half of 40 is 20. That's going to be the relationship that we're going to have with these inscribed angles, all right? So it's not like it's a formula to memorize, it's a concept to understand. If we believe that it's true, then we can just cut this measure in half. Or if we know the measure of this angle, we can double it to find the measure of the arc. So if I know that this is 40 degrees, then that means that this arc is twice as big. It's 80 degrees, all right? Half of the arc equals 40, so double both sides. 40 times 2 would give us the 80. All right, whoops, I went a little too quick. So in this case, I would like for you to try to draw your picture as best you can in your notes there. And we have some situations that we want to try to explore. We have this arc right here, PT, and its measure is A degrees. We're going to figure out what A is. Well, that arc is the intercepted arc for this inscribed angle. So I know that 60 is equal to half the measure of arc PT, all right, which means that 60 is equal to half of A. To solve this equation, I need to multiply both sides by 2. I don't usually show the algebra, I just kind of do it. So that means that the measure of that arc is 120 degrees. 120 degrees is equal to the measure of arc PT, all right? We solved for A. Now, in order to solve for B, we're going to find the measure of this angle PRS, and the measure of that angle is going to be, again, half the measure of this arc PS. I don't have to call it PTS because it's not bigger than a semicircle. So B is going to be half the measure of arc PS. B is going to be half the measure of arc PT plus the measure of arc TS. And so I'm doing a little bit of addition. I've got the 120 degrees plus the 30 degrees. And so B is going to be half of 150 degrees. So that means that B is equal to 75. All right. If you had trouble following any part of that, please make a note in the comments, or in the comments, not in the comments, or you can if you want to, but in the margin of your notes. That way we can have a conversation. I'm not a real YouTuber, guys. Leave a question in the comments. I'll get right back to you, because I probably won't. But if you put them in your notes and we talk about them in class, that's really for the W. All right, some corollaries. And so these are some fun extensions to this conversation. Two inscribed angles that intercept the same arc are going to be congruent to each other. So here's what this is saying. If this is the intercepted arc, then no matter where I draw the angle, here, or there, or there, or here, this angle is going to be the same measure as all of the other ones. It has to be half the measure of the same arc, so of course they're going to be the same measure. If we have an inscribed angle inscribed in a semicircle, then it must be a right angle, right? Half of 180 is going to be 90. So this is kind of a neat trick. We could actually draw this anywhere, and this would be a right angle, that would be a right angle, right? Because they're all going to be congruent. No matter where I put this, I'm going to make right angles. These segments are going to be perpendicular to each other. No matter where I put point T, it's going to be half of the 180, half of the semicircle's measure, so it's going to be 90 degrees. And finally, in this last bit, this one's maybe a little harder to follow. But if the whole circle is 360, right, then this major arc and this minor arc together add up to 360. All right, that makes sense, Mr. Hibbett. This and that together make 360 degrees. Well, that means that half of this red one and half of this blue one need to be half of the 360. So that means that these angles are supplementary. All right, the angle at S and the angle at U are going to be supplementary because they are added together, they are half of the whole circle, and so they are going to be 360 degrees. That also means that this direction, the measure of the angle at R and the measure of the angle at T, are also going to be supplementary. They're also going to be 180 degrees. So that can let us create some equations, can help us hopefully have some understanding. This right here is one of those things that we don't want to have to do a lot of work or thinking. If we understand these relationships, then we can say, oh, these opposite angles for this quadrilateral inscribed in a circle are going to be, these opposite angles are going to be supplementary, all right, are going to add up to 180. All right, so let's apply that. In this particular case, all right, we need to find the measure for angle 1. Angle 1 is going to be half of this semicircle. So the measure of angle 1 is 90. All right, there's not a ton of work to do there. Next, these are going to add up to 180. These are going to add up to 180. All right, this is, again, for a semicircle. All right, these are inscribed in a semicircle. They're intercepting this diameter and this semicircle. So the measure of angle 1 is equal to 90, so is the measure of angle 3. For the measure of angle 2 and the measure of angle 4, we kind of have to think about this in a couple different ways. First, we're going to figure out the measure for angle 4. The measure for angle 4 is going to be half of 60 and half of 80. And so the measure of angle 4 is 70, which means if these opposite angles are supplementary, 4 and 2, then 70 plus what makes 180? 70 plus 110. Right, so I did all the explanation of why these are the measures. If you need to write down any equations, oh, these are going to be 90 because they're half of 180, great. If you need to do half of 60 is 30, half of 80 is 40, add those to get 70, et cetera, then do what you need to do. All right, if this angle is 38 degrees, then this arc is twice that. I don't need to know that this is 76 degrees. I can know that, but I know that this angle is intercepting the same arc, so the measure of angle 2 is also 38. You could say 38 times 2 makes 76, and half of 76 is 38. You could do that. Or you could just say, hey, these are going to be the same, using the fact that inscribed angles that intersect the same arc are congruent to each other. So keeping all these fun facts straight is really the big challenge for the majority of this work today. Just making sure that we understand, hey, these inscribed angles are intercepting the same arc, so they're going to be congruent. These are intercepting a semicircle, so they're going to be right angles. Here, these are going to be supplementary angles, angle 2 and angle 4. So it kind of helps us think through all of that awesomeness together. All right, the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So here is a tangent, here is a chord. This angle right there is going to be half the measure of this red arc. Likewise, this angle here is going to be half the measure of this major arc. So let's apply that. Pause the video if you need. I went a little quickly through that. So here we're going to know that the measure of this angle is going to be half the measure of this arc. All right, but we know that the measure of arc JL is going to be twice as big as this inscribed angle. 35 is half the measure of that arc. So 70 is the measure of arc JL. It's supposed to be an arc. It made it look like a segment. And x is also half the measure of that same arc JL. So x is also half of 70. X is going to be 35. All right, we had to do a little bit of work to find out what this arc is so that we could use it to take half of its measure to get this. So these angles are actually congruent to each other, the x and the 35. All right? This is going to be a right angle. How do I know that? Because this is a diameter, therefore this is a semicircle, and the angle at J here is going to be this QJL is going to be a right angle. So that means that y and 35 have to be complementary. All right? The other way to do that is to say, hey, I found that of this whole semicircle here, I know that this is 70 degrees. So this is 110. And then y is also half of 110, which is going to be 55. So we could find it a couple different ways. Folks, this is just kind of using all the tools that we have under our belt. Strategically, this lesson is kind of towards the end after we've done a lot of work with the intercepted arcs, the measures of arcs, all adding up to 360, a semicircle being 180, et cetera, et cetera. So we're using that stuff strategically to make sure that we can review that stuff from the beginning of the unit as we engage with thinking about this content as well. Please let me know if you have questions on anything with Theorem 10.9 or Theorem 10.8. All right, finally, this last little bit. RS and TU are diameters. That's very helpful because that tells us that we have a semicircle here and a semicircle there. That's really important. Find the measure of BRT, which again is going to be half of arc RT, and TRS, which is going to be this whole thing. Oh, I'm sorry, angle TRS, not the thing here. TRS is going to be this angle right there. So these angles, we should know that these two angles are going to be 90 degrees, right? They're going to add up to 90 degrees. How do I know that? Because BR is going to be tangent to the circle here. And so that's really our exploration. So first, we want to make sure that we understand the measure for this angle, the measure for this angle, right? These are going to be making together a straight angle. So this we know is going to be 54 degrees, right? If I add 4, that gives me 130. If I add 50 more, that gives me 180. So this is 54. Which means that this arc is 54. This is 126 degrees because that's 126 degrees. Now, what's neat about this is if I know the measure of this for the semicircle, I could find that 54 by doing 126 subtracted from 180, or I could find that this is 54 doing 126 subtracted from 180 and then copying it over there, having the same measure. The measure of this angle is going to be half the measure of arc RT. So we're going to find that the measure of angle BRT is half of 54. So the measure of angle BRT is 27. And since these two angles are complementary, we know that 90 is equal to the measure of angle BRT plus the measure of angle TRS. So 90 is equal to 27 plus the measure of angle TRS. And so, subtract 7 and 20. That's going to give us 63 is equal to the measure of angle TRS. All right. Please let me know what questions you have. Obviously, another way that we could do this is we could recognize that this is also 126. So this is 126, and this inscribed angle is half of 126. Which is also going to give us 63. So there's a couple different ways that we could have approached that. Obviously, whichever way you do it is going to depend on which way you're thinking about it. And so you can approach these different ways, but we obviously want you to be as successful as possible. So think of it in all the different ways, but you only have to do it once. Please let me know what questions you have, and I look forward to seeing you in class.